Well, I made it back from Iceland once again. Question show time. Your questions, my answers. As always, wherever you are on my channel, if a question pops into your brain, just type it in. I'll gather them up and answer them right here. Stick around. We got a special guest answerer at the end, so let's get into it. Jason Murphy. Just wanted to say thanks for all the effort you put into your videos, podcasts, and general outreach. I look forward to your videos each day. One question, when is the Weekly Space Hangout returning? Or is it? The Weekly Space Hangout never went anywhere. We just set up its own channel and are posting the videos over there. Morgan Renberg and Kimberly Cartier and Paul Sutter have joined me as permanent co-hosts for the show, and every week we round up all of the big space news that's happening, bring in special guests, people from NASA, astronauts, and interview them, and it's a great time. So if you're into sort of like what current space news is happening, check that out. I'll put a card here, I'll put a link in the end, I'll put a link in the show notes, I'll broadcast it into your dreams, and you should go make sure you subscribe over on the Weekly Space Hangout channel, and you'll get that every week as well. Tons of content. Also, there's a podcast, and I don't know about you, but I like to receive my knowledge via podcast. So you can do a search for the Weekly Space Hangout wherever good podcasts are found, and you'll be able to get it. Also, you can get this show as a podcast as well, both a video podcast or an audio podcast. So if you don't want to have to come and watch it on YouTube and you just want to listen to it while you walk, you can do that too. Very convenient. ASIM source. NASA should work with SpaceX. Seems like a huge waste since reusable tech has proven at this point. All right, we're going to go into a whole bunch of comments that people made after I talked about the RS-25 engine, and it happened, sort of the timing of that was just as the Falcon Heavy was taking off, and I got a pile of comments very similar to this, and there's some more questions, I'll get into those in a second. So, SpaceX, their biggest customer is NASA, right? So NASA has signed up to buy rockets from SpaceX. The Dragon capsules that carry cargo up to the International Space Station, those are done by SpaceX. NASA pays for them. Other science missions have been done and are being queued up to be done on SpaceX rockets. You can bet that now that the first Falcon Heavy launch has gone off, NASA's going to be signing up for Falcon Heavy missions. Really, I've talked to a bunch of people at NASA, and sort of one of the really interesting things here is that at $90 million a launch with the Falcon Heavy, that is a factor of 5 cheaper than some of the other rockets that are out there. And so for people who work at NASA, that allows them to pretty much get double the science done. They can pretty much do 2 science missions instead of 1 science mission. So to say that NASA's missed the boat and doesn't know what's going on, like, SpaceX probably wouldn't be doing what it's doing if NASA wasn't there to be its biggest customer. So I think it's just really important to sort of understand that perspective. Yeah, absolutely. Now the Falcon Heavy has launched. You can bet that NASA and the other space agencies are going to buy flights on the Falcon Heavy. And then when the BFR arrives, you can bet that NASA and other space agencies are going to buy flights on that. So I think it's not like NASA has any problem with SpaceX. They would love to be able to buy as many inexpensive flights to space as they can, and SpaceX is demonstrating that these are possible. Mojo Waters. I love your views on NASA. I worked on the shuttle program at KSC for 25 years, and I don't truly like it when people hate on NASA. People forget the amazing things NASA has pioneered and the amazement in people's eyes when they watch the shuttle launch. I believe once NASA starts sending up our astronauts, the public will begin supporting NASA again. People right now are so obsessed and fixated on the prices the companies are paying for launches. When NASA doesn't just launch, they pioneer cutting edge and risky technology. That is awesome that you worked at the Kennedy Space Center for 25 years. Thank you so much for your contribution to space exploration. That's amazing. And I know me and many of the people on this channel, we all appreciate what you did. I can see why you're frustrated, that people are frustrated at NASA or have a lot of kind of grief to give to NASA, especially when you see these wondrous things like the Falcon Heavy launch. It's like, it's a lot of the accomplishments that NASA made with the space shuttle, with the Apollo program, with the Gemini program, humans on the moon, and then all of the other advances in materials and robotic exploration of the solar system. I mean, there's so many things that NASA has done, and the amount of the budget, of the U.S. budget, that is dedicated to NASA is about 0.5%. So the total amount of budget is actually very small relative to, say, the military budget and social services and things like that in the United States. It must come from some like sense of kind of like excitement, but also frustration and people wanting to try and kind of get the best bang for the buck. And so when you look at the fact that the SLS is going to be costing $500 million to $1 billion a launch, while SpaceX, for example, the Falcon Heavy is going to be $90 million to $150 million to $250 million per launch. Like, there's significant cost savings. And so I can kind of understand why people are frustrated. And where I stand on this really is that the commercial space industry's job is to turn access to space into this commodity. That if you want to launch space, there's going to be a bunch of companies, SpaceX, Blue Origin, Virgin Galactic, who knows who's going to be out there, and you're going to be able to compete, price shop around. If you've got a small rocket, you can go with an Electron. If you've got a big payload, you may be only able to use a BFR. There's going to be all these options. And that NASA's purpose is really to help continue to break ground, to work on the new projects, the kinds of uncertainty that commercial companies just can't dedicate the resources to because they need to remain profitable. And I think that the SLS is this sort of perfect example of where NASA has sort of remained a little too long in the sort of in moving into the commercial launch area. But, and I'm going to talk about this in a second, like, that's understandable because heavy lift rockets, as heavy as the Falcon Heavy, didn't exist a month ago, right? Like, you know, and it is 5 years later than SpaceX was telling everyone that it was going to be arriving. So it's not surprising that NASA didn't wait to launch. You know, they kept building the SLS because that was the way they were moving, and that's what they had, and that's the technology. There are thousands and thousands of people who worked on the space shuttles, and now they're working on the SLS. There's a much bigger issue that's kind of coming down the pike when the BFR shows up and it's able to launch really super heavy payloads into space, heavier than even the SLS. What, for a fraction of the price? What then? And I think that is going to be the bigger kind of existential crisis that NASA is going to have to deal with. And the last thing is that it's not NASA's fault, right? That we've done videos about this before, that there is a political system that is shifting back and forth, that is changing priorities, that is rewriting, cutting budgets, and really making it very difficult for people who work at NASA to have a long-term consistent goal that they can reach. I would be super frustrated if every couple of years everything that I've been working on got scrapped because, for political reasons, the new administration wanted to change where everything was going. So, again, thank you for your work at Kennedy Space Center, and here's to a great future of space exploration for NASA and for SpaceX and for all the others. Luke Ranieri. Wonderfully done as always. I'm a big fan of SpaceX and also Robert Zubrin's works, and increasingly skeptical of SLS's prospects. Do you think there's a valuable argument for defunding SLS and directing those funds to BFR as a partnership program? Would SpaceX be able to prepare BFR faster with much more money? SpaceX is kind of already getting money from NASA. I mentioned that earlier, that SpaceX is, you know, their biggest customer is NASA. They buy the Dragon capsules, they're doing scientific payloads, they're setting up to be able to send astronauts to the International Space Station. A lot of money is going from NASA to SpaceX, and that money has been invested in things like the Falcon Heavy and is now being invested in the BFR. And so I don't know whether, I mean, I'm sure SpaceX would appreciate like a bigger investment from NASA, but I think if I was Elon Musk, I would be trying to build and grow SpaceX mainly on the cash flow and investments coming in from the various commercial partners. It's a very robust way to grow your rocket ship company, as opposed to depending on, again, this You know, what if a new administration comes in and they decide that they want to build their own rocket system again, and they cut the funding for the BFR, and then SpaceX can't continue the development of that rocket ship. So it makes more sense for them to try and bootstrap up their rocket systems through cash flow and not be dependent on some outside firm. And I think this is how we got to this problem in the first place, where everyone is waiting for someone else to get this done, and then nothing ever happens. I don't think that NASA will or should cancel the SLS right now. The Falcon Heavy was a very serious and very significant demonstration that there's a very powerful reusable launch rocket that's now available. But when you compare them, you know, the Falcon Heavy in its reusable mode, I think can only loft 30 tons, metric tons, and in its expendable mode, it can do 64 tons, while the SLS in its Block 1 configuration is going to be able to do 70 tons, and in its Block 2 configuration will be able to do 130 tons. So the SLS is still a significantly more powerful rocket, even than the Falcon Heavy. The BFR rewrites all the rules, right? It's going to be more powerful than the Falcon Heavy, more powerful than the SLS, for a fraction of the price. And at that point, if these things are flying and they're launching payloads and they're returning to Earth and it's all working, then I think NASA would have a really hard time justifying to continue the development of the Space Launch System. But the question is, like, we've seen that the Falcon Heavy has taken years longer to develop than anyone was expecting. SpaceX says they're going to launch the BFR. They're going to start tests with the BFR of the spaceship part maybe next year. But when's it really going to come together? Is it going to take 5 years later? Is it going to take 10 years later? Does NASA fire their entire workforce and then just wait for SpaceX to get these rockets flying? Like, I think that when the BFRs are flying, when it's clear that the prices are what Musk was saying, when the hype is over and the reality has arrived, then I think it's time to retire the Space Launch System and move to buying flights on the BFR. And I wouldn't do it before then if I was running NASA. Brian Bagnall: they should cancel SLS immediately. Such a waste of resources, totally redundant and inefficient compared to SpaceX. That's not true. The SLS is a much heavier lift vehicle than even the Falcon Heavy. So if you want to launch these gigantic payloads, if you want to do the Europa Clipper, if you want to send the EM-1 mission that's going to have humans go out to lunar orbit, you need a heavier lift vehicle, and that right now is the SLS. When the BFR arrives, when the tests are done, when the prices are available, when NASA can put their cargo into these BFRs, that's when I think SLS should be canceled. Chad Baptiste: I've been watching The Expanse recently, and despite its obvious magnitude brilliance, something dawned on me. Would the constellations still be the same based on our orientation in the solar system? Say, for example, would Orion still be Orion when viewed from Ganymede as it would from Vancouver? I love The Expanse. I think The Expanse is my favorite science fiction television show. I'm sorry, Star Trek. I'm sorry, Carla. Yeah, she's just like, no. But she likes The Expanse too, so. But if you went up to Ganymede, would the constellations look any different? No, they wouldn't look any different. They would look, from your eye, essentially exactly the same. But astronomers do use a technique that's kind of like that to be able to determine how far away stars are. So when astronomers look up into the sky, in one season, say in the summertime, they can measure the angle to a star, and then 6 months later, when the Earth is on the other side of the sun, they measure the angle to that same star. And they can measure these stars, or a foreground object, moving just a little bit back and forth. And so you can see that little bit sideways motion, and that tells you sort of how you can measure the distance to how far away that star is. Now, if you went to Alpha Centauri, the constellations would look roughly the same. If you went a couple of hundred light years away, the constellations would look roughly the same. Some would start to look a little weird. And if you went, thousands of light years away, then the constellations in the sky would start to look pretty messed up. But for anywhere here in the solar system, the constellations will look exactly the same to your human eye. wherever you went. Another Iceland. Big rockets are exciting, but I can't stop thinking about the amount of pollution these high rockets dump into the atmosphere. What's your take about that? Yeah, some of the rockets, I mean, it depends on the kind of fuel that the rockets are using. And some of them, you can really see, like when you see some of these launches of some of these rockets, when you saw that RS-25 burn in the last episode that I did, it's firing out, hydrogen and oxygen. They're mixing together. The output is water vapor. It's a very clean rocket system. But when you see, say, the solid rocket boosters, they put out like just these white clouds of stuff. Or the kerosene engines that the SpaceX use. I mean, there's a lot of particulates that are coming out. When you compare the amount of pollution that's coming out of rockets compared to airplanes or cars or things like that, it's a fraction. But you can imagine some future there will be more and more pollution that's created, and it will eventually be a problem. This is one of the reasons why the BFR from SpaceX is so exciting, is because it's going to be using methane. And one of the things it'll be able to do is they'll have a plant, a solar powered plant that will bring in water, pull out carbon dioxide out of the atmosphere, perform some chemistry on them and create methane as a fuel, which is a perfectly good rocket fuel. And so it'll be carbon neutral, which is really exciting for a rocket that's going to be generating this much, gas and, using up this much fuel. For it to be carbon neutral is a really great idea. And so that's why I think hopefully in the future, most of the rockets will be, either liquid oxygen, hydrogen, or this liquid methane that will then be carbon neutral. Michael Gusevsky. How do you find questions? Do you look for question marks? I read all the comments on every video. YouTube's got a handy way so you can see all the new comments that have come in, and when I'm working on my question show, I just go through the questions, or as I'm answering questions, and I also like to answer the questions. So you'll see I try to answer literally as many questions as I am physically capable of doing. So if you have a question, just wherever, you should watch any and all of the videos, and wherever you see one, question pops in your mind, just write it down, and I'll see it. I see everything. Benjamin Lefebvre. Why is Mars Insight launching from Vandenberg? Mars Insight is the next mission that NASA is going to be sending to Mars. It's going to be launching in May 2018, and it's going to be going there, it's going to be landing, and it's going to be essentially trying to figure out what's inside Mars. It's going to be able to detect the movements of the planet. It's going to be able to find like geological information. And so why is it going to be launching from Vandenberg, which is on the West Coast, just outside of Los Angeles? From what I understand, it's because it has to launch on an Atlas rocket, and the East Coast launches of Atlas are filled up, and so they queued it for a West Coast one. What's great is that when these, remember the SpaceX launch that happened a couple of months ago over Los Angeles, people freaked out because there was this incredible trail from this rocket in the sky. And hopefully by the time you're seeing this, there will have been another one from another SpaceX launch that went out of Vandenberg. And again, if you're on the West Coast and you're and when these launches are going to happen, go watch a launch. Go watch a launch from Vandenberg, and it's awesome. Jax. How come the two Voyagers are still alive and functioning and aren't broken because of the temperature, making them very cold? They could freeze and start icing. As they move very fast, they could break. The Voyager spacecraft and a bunch of the NASA missions are powered by a chunk of plutonium that is decaying and turning into other elements and gives off a tremendous amount of heat. Now they use that for electricity, but they also use that to just keep the spacecraft warm. And do you remember The Martian? I don't know if you saw the movie The Martian, and at one point Matt Damon goes and he digs up this sort of cylinder that's really, really hot, and he uses it to keep the vehicle that he's driving around in warm. That is the same kind of nuclear battery that is on board the Voyager spacecraft. It's on board the New Horizons spacecraft. There's one on Curiosity, and they put off a lot of heat and they keep the spacecraft warm. It is a big problem. Spacecraft can't get cold. If they get too cold, then they die. And so they need to have some way to keep themselves warm. Irritable John syndrome. What happens to white dwarfs when they burn out? Do they become a gas giant or a planet? Do they fade into a brown dwarf? When a star like our sun dies, it grows up, becomes a red giant star, and then it compresses back down and becomes a white dwarf. It's essentially dead. And then over the next forever, it cools down till it eventually becomes the background temperature of the universe. So just a couple of degrees above absolute zero. And the term that astronomers have for this is a black dwarf. So I guess it's a white dwarf, but it is cooled down so that it is completely black. And there are none yet. The universe just isn't old enough for any of these white dwarfs to have completely cooled down. But in the far, far future, billions, trillions, trillions, quadrillions of years, you will have all of the white dwarfs will have cooled down to become these black dwarfs. BBF09. So gravitational waves are confirmed real now, and they carry and radiate away energy, lots of it. So if you can whirl or oscillate black holes, it must radiate energy away, and by mass energy equivalence, that must mean that the mass must come from the black hole. That is a great question, but I'm not going to answer it. I'm going to let a guest answerer, Emma Osborne from the University of Southampton, to answer it. Emma's got her own YouTube channel. You should totally check it out. And the best part is that she does these great chalk drawings on blackboards of the sort of the physics involved in the various things that she's lecturing about. She also has a great Instagram channel, and I'll link all those things up here and in the show notes, and you should definitely follow her to find out more information about physics, specifically gravitational waves, black holes, things like that. All right, take it away, Emma.
Hiya, this is an excellent question and thank you very much for asking it. But actually it's a little bit of a trick question because the black holes, as they're colliding, they can't release mass in the form of gravitational waves. And that's because the mass itself would have to travel faster than the speed of light to leave the singularity and escape the event horizon. What's actually happening is the two black holes, as they orbit each other, they're experiencing the gravitational field of the other black hole. So each black hole is held in the gravitational potential energy of the black hole it's orbiting. So the further away the black holes are from each other, the greater the gravitational potential energy there is between them. And as they orbit towards each other, they lose energy in the form of gravitational waves, which causes them to move closer. The energy they're losing is actually the gravitational potential energy. And the strength of this energy depends on the distance between them. So the closer they are, the more they release. Now, because we're talking about black holes whose gravitational fields are incredibly strong, when they get really close, they use a tremendous amount of energy. Because energy has mass, which we know from the equation E equals mc squared, it's easier to quantify how much energy is being lost by considering it as a mass. And that's why when the first two black holes that collided that was detected, they lost the equivalent of 3 masses of the sun. So I hope that answers your question.
All right, thanks, Emma, for answering that question. Again, way beyond my pay grade, so it's great to have someone jump in and guest answer. That wraps up our question show. As always, wherever you are on my channel, if you have a question, just type it in, and I will gather them up, and I'll answer them here. I'll see you next week.